Alright, so we are going to continue with Newton's second law of motion. Newton's second law of motion, the second law of Newton. Okay, so last time we did the first law, and I actually explained it in such a way that if you watch it, maybe you haven't watched that video, please watch that video. If you watch that video, I'm telling you, I'm assuring you, you will never forget the first law of Newton. You will never forget. If you watch that video, even if you complete your education, you still be remembering that law. Will be still remembering that law. I'm going to explain the second law in the same way. I want you to understand these laws. I want you to understand these laws. Maybe, by the way, if you haven't actually subscribed to this channel, make sure you subscribe and make sure you actually click on the notification button. On this channel, we do not only learn physics, we learn chemistry, biology, and also mathematics. So you'll be enjoying all those subjects through this same channel. So make sure you subscribe and make sure you click on the notification button. Okay, so I want to explain. Of course, I'm going to tell you, I'm going to read what this law states. And then at last, I'm going to give you a powerful explanation in such a way that you will never forget this law. Because as I was saying, these laws are very important in physics. Some questions actually require you to apply these laws for you to actually handle them well. So make sure you understand these laws. And I do not want you to actually, remember we say swatila. No, I do not want you to swatila these laws. I want you to actually master these laws. And I'm sure at the end of this video you will master Newton's second law of motion in such a way that even if you just from waking up from your sleep, you can give someone a powerful explanation about Newton's second law of what? Of motion. Okay, so let's get started. This is the second law of motion. What does it state? Newton's second law of motion states that when a force is applied on an object, that force will produce an acceleration in the direction of the applied force. That is the first part. I want you to actually get this concept. That is the first part of Newton's second law of motion. When you apply a certain force on a certain object, that force which you have applied will produce an acceleration, and that acceleration will be produced in the direction of the applied force. But what is the second part, which is very, very important, which is crucial? The second part is saying this acceleration is direct proportion to what? To that force, to the applied force, but inversely proportion to what? To mass. So I want to break it down so that you can actually understand, you master this law, because what is important is to understand, because if you understand, you will never forget. Okay, so what does it mean? What does it mean? So let's say, for example, you have an object here. You have this car. Okay, you have this car, and then okay, I'm not an artist, so you pardon me. Anyway, yeah, it is nice now. Okay, so you have this car, and this car, it is moving this way. Okay, let me just give you the direction. Maybe you cannot know the way I've drawn it. You may not know the direction yet. It is moving this way. So now, imagine there is no fuel in this car. Then it has stopped. So now, imagine you are going somewhere. Maybe this is your place. This is where you are going. Okay, so this is where you are going. So now, what will happen is that for this car to move, you need to apply a certain force so that it can actually reach your place. So now what will happen is that maybe you're going to call one or two people to help you to actually push this car. Okay, so according to the law, according to Newton's second law of motion, Newton's second law of motion states that when a force is applied on an object, in this case, a certain force is applied on this car. This force which has been applied, let's say for example, the force which has been applied, is 20 Newton. Yes, 20. 20 newtons. This force has been applied on this car. So now, this force which has been applied will produce an acceleration. Acceleration. So this is a force. This is a force, 20 newton. This force will produce an acceleration. And that same acceleration is the one which will cause this car to actually start moving. I hope you're getting it. So now, this acceleration will be in the direction of the applied force. So if it means this force is applied in this way, then this car will produce an acceleration which will be in this same way. I hope you're getting it. So that is what it means by saying the acceleration will be in the direction of the applied force. The acceleration will be in the direction of the applied what? Applied force. So that is the first part of what? Of Newton's second law of motion. When a force is applied on an object, that force will produce an acceleration in the direction of the applied what? Of the applied force. So now let's go to the second part, because all these parts are very crucial in such a way that you need to understand them, you need to know them. So now, what does the second part say? So the second part said to say, this same acceleration which has been produced by this force, this same acceleration is, I want you to get me clear, is directly proportional to what? To the force, but inversely proportional to what? To the mass. So mathematically, let me just express it, and I'm sure you're going to know a certain formula, and that formula I'm sure you will never forget. You will never forget it in your entire life. So let me give you this explanation mathematically. So what you are simply saying, that's why I'm sure you know the formula for force. When you want to calculate force, the formula we use is mass times acceleration. Mass times acceleration. This is a formula we normally use. So this formula, actually the one who came up with this formula is Newton, based on his second law. I hope you are getting it. So now, let's assume, since we are talking about acceleration, so now let's assume that we want to find acceleration. So what are we going to do? We are going to actually make this acceleration the subject of the formula. So what we are having, for us to find acceleration, we are going to have something like this. I hope you are getting it. I hope you are seeing what I'm doing. So this is what exactly this statement, last part, means. When you apply a certain force on an object, that object will produce, that force will produce an acceleration. And that acceleration is going to be direct proportional to what? To the force applied. So mathematically, this is what it means. And when you talk of something which is direct proportional to something, this is what it means. This acceleration will be direct proportional to what? To the force. To the force. And what does this expression mean? So this expression means that this acceleration depends on the force. I hope you are getting it. This acceleration depends on the force. If something is proportional directly, it means if you increase the force, then even the acceleration will increase. So if you are pushing a car, in that case, in that example, let's say we are pushing a car. Okay, let's say we are pushing a car. This car is being pushed. So let's say, for example, it is one person. At first, it is only one person who is pushing. Yes, who is pushing this car. Then maybe we call another person. Maybe this person is exerting a certain force of 20 newtons. So it's exerting a force of 20 newtons on this car. And this force is being applied in this direction. Then we call another person. If this 20 newton, by the way, if this 20 newton is producing an acceleration of maybe 1.5 meters per second after second. So if that is what this force is producing, meters per second, 1.5 meters per second squared, or meters per second every after second. So if that is the acceleration, then if we call another person who is also exerting 20 newtons, if we call another person who is also exerting 20 newtons on the car, and that simply means that now we are going to have 40 newtons. That is the force we are going to have. That simply means that since we have increased, that is what this statement means. I want you to get it. Since we have increased the force, even the acceleration is going to what? Is going to increase. Even the acceleration is going to do what? Is going to increase. I hope you are getting it. So that is what it means when you talk of something which is in direct proportion to each other. So if you increase the force, even the acceleration is going to be what? Is going to be increased. If you reduce the force, let's say for example you have reduced, maybe at first 2 people were pushing the car. we are pushing the car. Then let's say for example one has gone, then only one has remained. That means that the force is going to be what? The force which is being exerted on the car is going to be what? To be reduced. So since the force has been reduced, even the acceleration is going to be what? Is going to be reduced. So that is all. Whenever you just hear that something is in direct proportion to each other, just know that when you increase one between those two things, even the other is going to be what? Is going to be increased. So that is what it means. So this is Newton's second law of what? Of motion. Newton's second law of motion. So I hope you will never forget this. Let me give you a summary of the second law of what Newton's second law of motion states. So when a force is applied on an object, according to Newton's second law of motion, it states that that force will produce what? That particular force will produce an acceleration. And that acceleration will be in the direction of the applied force. There is no way you are pushing a certain object. In this direction. Then suddenly you just see it is moving in this direction. No, there's nothing like that. If you are pushing an object in this direction, then this direction will start moving in this same direction. Have you seen? So the reason why that happens, it is because of what? Newton's second. That is what Newton discovered, and he named it as his second law of what? Of motion. If you are pushing a certain object, that object will move in that same direction of the applied force. So that force, that acceleration, which will be produced, which will cause that particular object to move, is direct proportion to what? To force. That simply means that if you increase the force, if the acceleration will be what? Will be increased. Let's say for example you have 20 newtons, and this 20 newtons is able to produce maybe, let's say for example 1.5, as I said, meters per second every after a second. So what will happen is that if you actually double these newtons, maybe let's say for example we have now 40 newtons. So if you have 40 newtons, then that simply means that even the acceleration will be increased in such a way that it will become now 3 meters per second every after a second, or 3 meters per second squared. I hope you are getting it. So that is what is going to happen. That is what it means when you say acceleration. That acceleration is direct proportional to what? To force. But that acceleration is inversely proportional to what? To mass. Let me explain it well. That acceleration is inversely proportional to what? To mass. So let me show you. This is a formula we use if you want to actually calculate force. Okay, let me just write it well. Force is equal to mass times acceleration. So if you want to actually, if in this case you just want to concentrate on acceleration and mass, what we are going to do is that we are going to make, if you want to calculate acceleration, we are going to make, okay, we are going to make, or maybe let me just say we want to concentrate, okay, we want to concentrate on mass and acceleration. What is going to happen is that this is what we are going to do. Okay, we are going to have something which will look like this. Okay, let me just do this. We are going to have something which will look like this. Force over mass. I hope you are able to see. So now let's assume we just want to concentrate on mass and acceleration. So we're going to have something like this. So this expression, whenever you just see this expression, if you see this expression, maybe you are writing any formula, then you see this expression which is just direct. Let me just write it in this way, which is just direct. Just know that those things are direct proportion to each other. But if you see this expression which is not direct, something is on top and the other thing is down here, just know that these two are inversely proportion to each other. And what does it mean when we say these two are inversely proportion to each other? That simply means that when one increases, one actually reduces. So if you increase the mass of the car, if you increase, let's say for example you have two cars. Let's say for example you have two cars. You have this one. Okay, you have a truck. And then you have another car which is just a small car. So you have these two cars. I want you to get it well. Which is just a small car. So I'm going to find that the mass which this car is having, maybe let's assume it's having 250 kilograms. Then this one is having 1000 kilograms or kgs. So you are going to find that when someone is just alone, then is pushing this car by exerting a force of 20 newtons. On this car, and then the same force is also being exerted on this small car, this same force of 20 newtons. You are going to find that this car will run faster than this one, will move faster than this one. The reason why? Because this car is having a smaller mass than this one. Have you seen? So the bigger the mass, the smaller the acceleration produced. The smaller the mass, the bigger the bigger the acceleration produced. So if it means this car is having 100 kgs, this car is having a bigger mass than this one. And for that reason, due to the fact that acceleration is inversely proportional to what? To mass. This car will move slowly as compared to what? As compared to this one. Because this one is having a mass of which is smaller than this one. I hope you are getting it. So that is what it means when we say this one, this particular thing is direct proportion to each other. This particular thing is inversely proportional to what? To each other. So that is all about Newton's second law of what? Of motion. Newton's second law of motion states that when a force is applied on an object, that force will produce an acceleration. That particular force will produce an acceleration. That acceleration will be in the direction of what? Of the applied force. And that acceleration is direct proportion to what? To force, and inversely proportion to what? To mass. That is all about Newton's second law of motion. That's why we have even this formula. Which is force is equal to mass times what? Times acceleration. This formula is based on this same concept. I hope you have enjoyed my video, and I hope you have actually understood my explanation. If you have any question, if you have any comment, make sure you drop it in the comment box. Make sure you drop it in the comment box, and make sure you put a like in the comment. I mean, yes, you put a like if you find this video to be what? To be very, very helpful. Otherwise, make sure you watch also my third video, where I'll be explaining the third law, the last law of motion. And that one is very interesting. That one is very, very interesting. So make sure you watch the next video so that you also understand Newton's third law of what? Of motion. Don't forget to subscribe, and also don't forget to click on the notification button so that whenever I upload a new video, you get to know. Otherwise, for now, we can end here.